pick up where we left off. We're on question number 12. Okay, identify the following as translation, rotation, reflection, or none of these. This is kind of along the same lines we saw a question like this last time. What do we know about translations, rotations, and reflections? They are what types of transformations? It's that I word that I ask you questions about all the time. And nobody knows the answers to. Isometric. Great, thank you. Do you know what it means? Does anybody know what isometric means? It's probably important. What is the term isometric? I'm going to even just write a new question on the test and say, what is isometry and what does it mean? Because I ask this question all the time. Matt, tell me. What does it mean? Same size, same shape. Right. It's going from A, B, C, D as a preimage to A prime, B prime, C prime, D prime. Is that the same size and shape? Same shape maybe, but same size? No. If this was anything, what would it be? Okay, it's not one of these, but what might it be in terms of a transformation that is not isometric? Dilation. Very good, right? So what type of dilation would we call it? Would it be an expansion or a reduction? I heard two things. Expansion, or we're going from here to here. Expansion or reduction? Expansion. Okay. We always go from no tick marks to tick marks. The more tick marks we have, the more transformations we've gone through. So our answer for number 12 is none of these. Okay, we're going to scroll back up to 13, and I am not going to guarantee you that this question won't be on the test. Okay, it's a tough question though. All right, requires quite a bit of math, but since the perimeter of the isosceles trapezoid is 55.9, AB is the mid-segment of WXYZ. If XY is 3 times ZY, find, basically it wants the lengths of all the perimeter points. Okay? Does that make sense? All right. So where do we begin with? Anybody know? Probably not. Okay. All right. So we know that our perimeter, 1, 2, 3, 4, 55.9. XY is 3 times ZY. Okay, so let's refer to this length here as X. We know it's an isosceles trapezoid, so that has the same length, correct? Okay, we know that XY, in terms of length, is 3 times the length of ZY. Okay, so, and then we have an unknown. Correct? We don't know anything about ZW. We don't know if it's the same length as ZY. We don't really know a whole lot there. Okay? All right. So what we do know is that 3x plus x plus x plus what we could call y is going to be equal to 55.9. Could we simplify any part of that equation? 3x plus x plus x plus y equals 55.9. Yeah, I could combine my x's. What's 3x plus x plus x? 5x. So we could simplify this to 5x plus y equals 55.9. Okay? We could hold on to that. Let's go ahead and hide that up here somewhere. 5x plus y equals 55.9. What do we know about mid-segments? They would be the average of the top and the bottom, correct? Okay. So in that sense, we would say, 3x plus y divided by 2 equals 19.35. Is that correct? All right, well, let's go from there for a second. Let's kind of simplify that. If I was just wanting to simplify this at least a little bit, what would I do with that 2 in the denominator position? Multiply by 2 on both sides. Okay, so I get 3x plus y. What's 19.35 times 2? 8.7. All right, let's double check. 19.35 divided by, or times 2, right? Times 2. 38.7, very good. All right, so we got this 38.7 here. 3x plus y equals 38.7. Okay? So if you'll notice up here, I have a 5x plus y equals 55.9. Down here, I've got a 3x plus y equals 38.7. Anything I could do with those two equations we've created? Set them equal to each other. Probably not. Let's I'll put them down here together so you see them. 5x plus y equals 55.9. Thoughts? Subtract. What's subtraction going to do? Anybody? What would you're not wrong, but what's subtraction going to accomplish? Let's say I subtract these two equations. Anybody know what's going to happen here? It'll eliminate my y's, okay? Because y minus y is going to eliminate. What's this going to end up solving for me? The value of x, right? Because what's 3x minus 5x? Negative 2x. Now that might scare you, but what's 38.7 minus 55.9? Negative maybe 17.2. Negative 17.2. What would I do from there? Well, I want to solve for x, correct? Okay, divide by negative 2. What is x? 8.6. Okay, now that's going to give me a whole list of answers, right? Because I know some things. If I go back to my original picture here of x, can that tell me what zy is? 8.6. Can that tell me what xw is? 8.6. Can that tell me what xy is? Multiply by 3 and get what? 25.8. All right, but I still don't know what y, or what I'm going to call y down here. How do I find out that? Okay, so let's look at it like this: 25.8 plus y divided by 2 equals 35, right? All right, multiplying, we did that. Right? 19.35 divided or times 2. What's that? 38.7. So we had 25.8 plus y equals 38.7. I want to solve for y. What am I going to do? Subtract. And I get y equals what? Anybody? 38.7 minus 25.8? 12.9. Okay, so you guys have the ability to scroll down to the bottom and look for the answer on 13, right? Anybody want to scroll down and see if we're correct? We're right? All of them? We got all of them right? Okay, 25.8, 8.6, 8.6, 12.9. Here's the thing, though. If this question shows up on a test, and it'll probably be those exact numbers, will you get credit if you don't know how to solve? You cannot, you need to be crude here, pull numbers out of your butt. Okay? Butt numbers. Okay? They have to come from somewhere. It has to make sense. Or you won't get credit for it. All right. 14. A tree casts a shadow of 23 meters when the angle of elevation of the sun is 28 degrees. Find the height of the tree to the nearest meter. It's a good question. Okay. All right. I'm going to start off by drawing a tree. Okay. All right. Does that look enough like a tree for you? Hopefully. Kind of. All right. Where's the sun? In the sky. All right. Probably over here to the left somewhere. Because this little black line right there is my shadow. Right? So we're going to get something that looks like that. We're going to ask, what is the height of the tree? Where do I put the 28 degrees? Does it go up here at the top of the tree, or does it go down here where the shadow meets the ground? Shadow meets the ground. And what was the big clue? Is there a clue in the wording here at all that would tell me where that 28 degrees go? Of elevation. All right, 28 degrees. And they told me that the shadow, we don't want to forget that, was 23 meters long. Does anybody know which trig function we would use to solve this? I heard tangent. I heard sine. Okay, tangent, sine, or anybody want to go cosine? All right. Sine uses what two things? What is sine? So it's SOA? Is that what we say? We say SOA? Sine equals opposite over adjacent? No. All right, so let's do a quick review. Sine is what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So let's talk about what it is that we have over here. What is the height of the tree in relation to 28 degrees? Is it opposite, adjacent, or hypotenuse? It's opposite. Okay. Does not share a vertex. Okay, opposite. What is 23? Adjacent. Okay. And what is this blue line over here? That's my hypotenuse. Okay. So based upon what we have to work with, which one do I want to use? Sine, cosine, or tangent? What do you think? Tangent. Let's use tangent. Okay? So I'm going to erase these. You guys should have those written down. All right. So I'm going to write tangent. What's the next thing I'm going to write? What goes next to tangent? What goes next to my trig function? My degree. Good. 28. And because tangent equals opposite over adjacent, I'm going to put h, which is my unknown, my height of the tree, over my adjacent, my known, 23. Now I want to solve for h. What do I do? Erica, what do you think? Multiplied by, what'd you say? Not 28, 23. Multiply by 23 on both sides. All right, so what we should get is 23 tangent 28 is going to be equal to my height. Okay, you guys have calculators, correct? What'd you say? 12.2? 12.2 what, Darian? Meters. All right. Somebody, if you haven't already, scroll down to the bottom. Let's see if Darian's right. They took it to the nearest whole meter, and it does say to the nearest meter, so we'll be careful about that. But yeah, 12.2 is probably the more accurate of the answers, but we are good with 12 meters. Okay? All right. Feeling good about things so far? Just kind of need a refresher on some of our trig functions. Go ahead. Probably not, but you do want to be specific, right? You do want to look at those things. All right, 15. All right, find the coordinates of the image of the point -3, 7 when it's reflected across the line y equals 10. That's tough. Okay, let's see if I've got a good place to do this from. I'm going to come over here. We want to reflect it across the line y equals 10, right? And what's my coordinate? -3, 7. Okay? Actually, I'm going to have to do this a little differently. Something like that. Let's go ahead and plot -3, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that should be this point right there. Is that pretty accurate? All right, what kind of line is y equals 10? Horizontal line. So horizontal means, well, we know what horizontal means. So I'm going to come up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This should be the line that I want to reflect it across. Okay? All right. So we are 1, 2, 3 from the line, which means how far above the line do I need to go? I need to go 6 above the line, so I double it. All right, so let's, and I don't mean, I'm not trying to make fun, but just so that we come back to a point where we're trying to make sense out of reflection. When you stand in front of the mirror, right, you may be, let's say you're 3 feet from the mirror, right? Your reflection on the other side is 6 feet from the mirror, so even really far away. No. Okay, so if we are, what you're saying, and I hope this is what you're saying, is that you want to count 6 up. Is that correct? You want to count 3 above the line. Okay? 1, 2, 3. All right, so we're going to be about right there. Okay, it's our point reflected. Now we have to find the coordinates of that point. Okay, well, did our x number change at all? No, so we know we're still at -3, and we added what to our y value? We added 6. All right, so we should be at -3, 13. Okay, but sometimes a visual kind of helps to see and make sense out of that. Okay, so when we're reflecting across a horizontal line, we want to find the distance of our y coordinate to that y. So what's the difference between 7 and 10? It's 3, right? And we're going to double that. Okay. All right, let's get back to this. Was that the correct answer? Yes. Okay, number 16. Decide whether this figure has line symmetry. If it does, draw all the lines of symmetry. Okay, does it have line symmetry? Can I fold that over and it map onto itself? Okay. Can I get anybody to come up here and actually draw one of the lines of symmetry? Mariah wants this. Okay, go ahead. Come up here and draw me a line of symmetry on our shape there. Very good. All right. Is that the only line of symmetry we can draw? Okay. Does anybody else want to come up and draw another line of symmetry? it on up here. Draw that other line of symmetry. Perfect. Are there any other lines of symmetry we can draw? What about this? Is that a line of symmetry? No. Why not? Because in a rectangle, you can't fold a diagonal and get it to map onto itself. So we only want the blue and the red line. Okay, so 2 lines of symmetry. All right, 17. Rotate triangle ABC 180 degrees about vertex C. Okay, so let's say I have A, B, C. Okay, we have a vertex of C, correct? Right there. And I want to rotate this 180 degrees about point C. The thing about 180 degrees of rotation is that each one of those points is going to go directly across that point, which means what I should get is A is going to come across here, B is going to come across here, C is going to stay put. So what I should get is A prime and B prime and C prime. That's 180 degrees of rotation about vertex C. Okay, does that make sense? All right. So you have to understand degrees of rotation and point of rotation. And I don't know what the answer key looks like on that. It should look similar to that. Okay? Number 18, find the volume of a sphere that has a diameter of 17.6 meters, both in terms of pi and as a number, using 3.14 for pi. Round your answer to the nearest tenth. So what do we need to know here going in? Is there any particular formula I need to know? Volume of a sphere. All right, can we tell me what the volume of a sphere is? Nobody can. How embarrassing for you, because I know it. Where would I find it if I didn't know it? I could Google it. Okay, 4/3. I heard that much. Pi r to the third. Okay? Does anybody notice about any of the information that they give me that I might have to change or do something with? Divide 17.6 divided by 2. Why would I need to divide 17.6 by 2? I need the radius, not the diameter. All right. So we're going to solve. We need 4/3 pi. What is 17.6 divided by 2? 8.8. Okay? What is 8.8 times 8.8 times 8.8? Right? That's 8.8 cubed. What is 8.8 cubed? Now multiply that by 4. Now divide that by 3. 908 point what? 62, but we want it to the nearest tenth. 908.6 pi meters cubed. Is that right? Is that the answer that's in the answer key? All right. What else do I need to do with this? Is this my final answer? All right. I also need to do what? Square root? Somebody says? No, I don't need to square root it. I need to solve this using 3.14 for pi. Do I want to leave this here? Yeah, because it asked me in terms of pi. We've done that. Now we need to take 908.6 and multiply it by 3.14. 2,853. Is that it? 0.1? 0.1 meters cubed. All right, so we need both those answers. All right, Feel pretty good about that? All right. Let's see. 19. Use the diagonals to determine whether a parallelogram with vertices -1, -2, -2, 0, 0, 1, and 1, -1 is a rectangle, rhombus, or square. Give all the names that apply. All right. All right, -1. Let's draw some tick marks through here. Okay, obviously you want to use graph paper when doing this. -1, -2, something like that. -2, 0, 0, 1, and what do we say? 1, -1. Let's see. This is why you want to use. Let's see. Make sure I didn't mess this up. -1, -2, -2, 0. Oh, my bad. I didn't mess up. Okay. 0, 1, and 1, -1. So I have a shape that looks like that. Okay, we've seen this question before, right? We've gone through a long explanation of this before. What does that look like? Square. Do I have to prove it? Yeah. Okay. And in order for me to prove something is a square, what do I need to prove? That it's a rectangle and a rhombus. Something is a rectangle. The first thing I need to prove is that it has four congruent angles, or 4 right angles. 4 right angles will be opposite reciprocals to each other, right? So I could find the slopes of each of those lines. This goes up 1 over 2, right? This goes down 2 over 1. This goes over 2 up 1. Okay, this goes down 2 over 1. Okay, so, right, I should see that I'm working with all the same numbers. Notice that this is going down 2 over 1. This is going up 1 over 2. This is going down 2 over 1. I should start to be able to put those slopes together and see the opposite reciprocals involved there, right? Right? The other thing is I need to prove it's a rhombus, right? What do I know about rhombuses? They have congruent side lengths. If I'm using 1 and 2 in terms of my right triangles, am I going to get the same hypotenuse every time? If I'm using 1 and 2, 1 and 2, 1 and 2, 1 and 2? Yes, I should. All right, now, for sake of time, I'm not going through and doing the Pythagorean theorem for you all those times, but that's what you need to show me. Okay? Does that make sense? All right. So show me that those 4 sides have the same length. Show me that that you have 2 sides that have the same slope and 2 sides that have opposite reciprocal slopes. Okay, that's going to give me 4 right angles. Any questions on this before I erase anything in terms of what's expected? No? Okay. All right. I don't know what time we get out of here on an early out. You would think that after we've done this all year that I would know that, but I don't. So, all right, verify that NQ is parallel to PR. All right, how would I do that? NQ is parallel to PR. Anybody know? I'll give you a hint. Proportions. Proportions. We know what proportion we would set up? Go ahead. NP over what? Yeah, you could do NP over QR equals what? Over RM. Sure. What is NP? 16 over 8, right? What's 16 over 8? Yeah. 2, right? All right, what's PM? 12 over 6. What's 12 over 6 reduced to? 2. Okay? They're proportional, therefore they're parallel. Okay? And they're going to give you a drawn out deal. So now it may not be NP over QR. In fact, it'll probably be NP over PM, 16 over 12, which is what, 4/3, right? And we should get 8 over 6, which is 4/3. So we're going to see that 4/3 to 4/3. Okay? All right. 21. 21. Find the probability. Again, just as a review, what is probability? It's something over something. Number desired over number total. All right, find the probability of spinner landing on new house. Give your answer as a fraction. What am I going to put for new house? 60. What is the total? 360. All right, as a reduced fraction, what is 60 over 360? 1/6. Okay, so I've got a 1 in 6 chance of landing on new house. Okay? Now, if that had been percentages, we would have had over 100, right? 100%. Okay, that would have been my total. Okay, 22. An experiment consists of spinning the spinner shown. All outcomes are equally likely. What is the probability that the spinner will land on 4? Express your answer in simplest form. Again, we want probability. So what number goes on top? 1. Number of total. There only 1 4 on there, right? So 1. Okay, what's the total? 5. Okay, is that the answer at the bottom? Hope so. All right, we'll stop there. You guys should have all the videos by the end of the day. Test tomorrow. Okay?